Well, let's pick up what this distribution of sample means. Please realize that we're taking 16 samples of size 2 with replacement. So I want you to think, if I'm replacing, what could happen if I drew a 2 first? If I drew a 2, could I put the 2 back and draw another 2? Well, of course. And that would have a mean of 2. If I look on row 1 there, sample 1, 2 plus 2 divided by 2 is 2. Could I draw a 2 first, put it back, and then draw a 4? Yes. And of course, the mean of 2 and 4 is 3. Could I draw a 2 and then draw a 6? Yes. And of course, that mean is 6. And you'll see here what I have from beginning to end, from top to bottom, is an exhaustive list of all the possible outcomes if we drew a sample of 1, put it back, and then drew another sample. I could draw a 2 first, a 4 first, a 6 first, and an 8 first. And then I could draw a 2 first, a 4 first, second, a 2 second, a 4 second, a 6 second, or an 8 second. And these are all the possible outcomes. And you see for each of those samples of 2, a mean has been collected. And over on the far right, what you have there, although we didn't necessarily intend to do it, is a quote-unquote distribution of sample means. Not a distribution of individual scores, but a distribution of sample means. Let's take a look and see what that would look like in a histogram. What you have there on the left is a histogram with all of those 16 means. And what you have there physically now is a distribution of sample means. I've got all 16 boxes there represented, and of course we're representing them continuously with upper and lower real limits. So let's say somebody asked a crazy probability question. They can ask this nutty question. What's the probability of drawing a sample mean with a sample of 2 that was less than 7.5? Just look at the graph. What's the probability of drawing a sample mean with a sample of 2 that's less than 7.5? As you can see, it's the great majority. It's left and 2 and less. You know, when we talk about less, it's to the left and less. And that would be 15 of the 15 of the 16 boxes. 15 of those 16 boxes, whatever that is a percentage, 0.93 or something. The probability of drawing a sample mean less than 7.5 from a sample of 2 is 15 over 16. What about less than 3.5? Just by looking at that pink distribution. Well, in that case, it's only 3 over 16. So I could actually ascertain a probability of garnering a certain mean from this distribution of sample means. I could do that just as I did with any array of individual scores. So please bear in mind what I have there in that sort of pink-orange histogram there are not individual scores, but they're each of the sample means that are over there on the right. So that's literally a distribution of sample means. Now, could I do that with an infinite number of means from an infinitely large sample? What did we have before? We had this silly rudimentary population with only 4 members in it, and we drew samples of only 2. So that's kind of a corny example, but it still produced something interesting. Now, what did it produce that was interesting that I want to draw your attention to? What's the mean of the distribution of sample means? I want to draw your attention to that. I hope you can tell by looking that the mean of the distribution of sample means is also 5. Now, why is that important? Well, because if you'll look, the original population had a mean of 5. That's kind of cool, isn't it? So the mean of the original population and the mean of the distribution of sample means will have the exact same number. In this case, 5 for both. That's kind of cool that it gathers around the same mean. And this is, by the way, what I just described, that the mean of the distribution of sample means and the mean of the original population from which it came are the same number. That's part of what we call the central limit theorem. And again, this is where I'm going to have to ask you to do a little reading ahead. The central limit theorem only asserts 2 things, and one of those 2 things is the fact that the mean of the population and the mean of the distribution of sample means are one and the same, which is kind of cool. Now, can we explode this into large populations of an infinite number of samples of a certain size? And do we have to go through this crazy exercise where we're doing it with some kind of grid that we had before where we're listing a mean off to the far right? Yes. There are many, many things I can know about that distribution of sample means owing to this central limit theorem, and that's what we'll pick up next.